Technological University. I'm sorry, yes. Okay, good morning again. Professor Bertil Anderson, President of Nanyang Technological University, Professor Van Norden, Chairman of Molecular Frontiers Foundation, distinguished speakers and VIPs, ladies and gentlemen, and teachers and students. Welcome to the second day of the 2012 Molecular Frontiers Symposium at Nanyang Technological University. For those of you who could not attend yesterday, my name is Yoo-hyun Park. I am the Asia Director at the President's Office at NTU. I also have the privilege to serve as the lead organizer for this event. It is great to see you all again today. Professor Miyawaki yesterday told me that it was the most fun he has ever had at a science conference. Thank you for your general comments. But for those of you who missed the first day of events, please do not worry. We have another fascinating and a world-renowned group of speakers lined up for today. Our distinguished speakers worked on the frontiers of cutting-edge technologies in biomedicine. These technologies have the potential to change the world, and yet would not have been possible without the imaginations of the speakers, who you will hear from today. The symposium will give students and local community the chance to meet the science superheroes. These are the pioneers and leaders working on the hottest trend in science and technology. Today again, we have participants from around the world watching the symposium live through online broadcast. Especially in Korea, we have again 10 high school students representative are joining us from the local Cisco office via two-way interactive feed. Shall we say hello to them? Hi, Korea
Hello.
again. Hi. Hello, great.
Good morning, Singapore.
Okay. So, thank you. For those of all of you watching this event online, you're welcome to actively participate in the symposium through Facebook and Twitter. Don't be shy to ask your questions. Today's opening remarks are a very special occasion. Sir Harry Kroto, currently the Francis Epps Professor of Chemistry at Florida State University in the United States, were unable to join us today in person and has pre-recorded his talk. Sir Harry Kroto was awarded the 1996 Nobel Prize in Chemistry for his discovery of Buckminster furanus, and it is one of the most interesting molecules in the whole world. And today, Professor Kroto will talk to us about his life in science. And now, please welcome Sir Harry Kroto.
It's a pleasure to be coming to you across the internet and talking about some interesting, and I think some serious issues, as well as some fascinating ones about science. And first we'll talk about the value of science to society. And people don't fully appreciate what they are. There are pros and cons. For instance, there are negative aspects of science, and accidents do happen. But actually, I think perhaps much worse is the fact that technology is used in conflicts, such as wars. And I think we should, in the 21st century, be able to avoid those. I think by and large, I think people would agree that science has provided great benefits to society. And in fact, in the 18th century, half of all children died by the age of 8. And that's the case in some parts of the world at the present time. In fact, if we think about what life would be like without science and technology, all these things would disappear. And that's just without chemistry. And in fact, physicists and engineers and biologists could say the same thing. Now, scientists work together to solve some of the big problems, such as look after the environment, such as improve world health, and understand how things work. That's a very important aspect, and in fact, enjoy making things. These are just some of the things that scientists do, and for the benefit of mankind. Now, many of you probably don't really understand what it was like in a world without anesthetics. This is an etching. There were no mobile phone images then, but this gives you an idea of what it was like to have an amputation without anesthetics. In fact, there can be no more humanitarian contribution to society than the gift of anesthetics to society from chemistry. Penicillin. Many of you have had antibiotics. Now this is a miracle, okay? You don't have to pray, okay? This works essentially every time. And in fact, let's look at blood poisoning in 1942. A year earlier, this little girl would have died, but penicillin was available in 1942, and in 3 weeks she was cured. And the problem is that bacteria are evolving with an immunity to antibiotics. Think about it. We could be going back to this, and we need brilliant young people like you to actually solve the problems of the future if we are going to avoid this retrograde issue. Okay. Well, what are the real scientists? Who are they? People don't fully appreciate who the scientists actually are. Many people think that basically these sort of old images that you know, such as Einstein, okay? You think that this is a famous scientist. But in fact, he's an imposter. He's not the person who did it. The person who did it was this guy, totally unknown. Yes, it's young Einstein. He was 24 years old when he did his most famous work. In fact, he was 17 when he first started to think of what it would be like to travel at the velocity of light. It's young people who actually are the people who have the ideas and imaginations. They might have to develop some understanding, but that is the people who made the big breakthroughs. Darwin, with his long beard, when he started to think about this book, he was young Charlie, 24 years old. He was a young man. And Clerk Maxwell, who originated these amazing equations, which are, I suppose, the biggest breakthrough of any kind, science or art, of the 19th century, which govern electromagnetic relationships, he was actually a young man like this, okay? Wee Jamie, with a little quiff on the top of his head. Rosalind Franklin took the most important photograph of all time. Yes, it's this, from which the structure of DNA was determined. Chandrasekhar was a young man of only 24 or so, who actually worked out that a star 1.5 times the size of the sun would collapse into a neutron star. It's young people who make the breakthroughs, like Jim Heath and Sean O'Brien and Yuan Liu and Jonathan Hare, who helped us in the discovery of the C60 molecule. What is fantastic about science is that it doesn't matter what country you're in, what color you are, what religion you are, we're all sort of governed really by the way the universe is. We speak the same language of the sciences, and here from Spain to India, from Holland to Syria. This is a community which doesn't know anything about the boundaries between nations. No patriotism and nationalism and all this stuff. No, this is bound together by the culture of the sciences. And the science is the same in Syria as it is in Spain, as it is in Taiwan, and as it is on Mars and on the other side of the galaxy. Now, how did I get to where I was? Well, one thing is I was fascinated by quantum mechanics. And this is a fundamental relationship of quantum mechanics, okay? JA times JB minus JB times JA does not equal 0. And that was very funny to me, and I was fascinated by that. And that led to an understanding of chemistry at a deep level. Consider the numbers 1, 3, and 5. Okay? 1, 3, and 5. And these numbers underpin the whole of chemistry. Why and how? But let's have a look at it, okay? The Earth orbits the Sun, okay? We use classical mechanics. And for an electron orbiting a nucleus, we use quantum mechanics. They're related, but in fact, classical mechanics is is the same as quantum mechanics, but related to larger objects, okay? And angular momentum is quantized. What does that mean? That angular momentum is related to a quantum number, J is 0, 1, 2, 3, 4, okay? Just accept that for the minute. And if you want to understand how your mobile phones and computers and lasers and digital cameras work, you really should dive into quantum mechanics. It's not that hard, and it just requires a bit of fairly straightforward mathematics. However, for a given value of J, there are 2 J plus 1 orientations. What does that mean? If something is spinning with an angular momentum J, it has 2 J plus 1 orientations. So what do you mean? J is 0, 2 J plus 1 is 1 orientation. When J is 1, 2 J plus 1 is 3 orientations. When J is 2, 2 J plus 1 is 5. And so we get basically 1, 3, and 5. Now then, 1, 3, 5, let's double that set, and double that set. Move this to there, and move that to there. Double this set here, and double that set, and double that set, and move that to there, and this to there, and that to there, and what have we got? Yes, the periodic table, based on the numbers 1, 3, and 5. And what's more, it explains the whole of chemistry, and therefore also all of life and biology, and all the useful bits of physics, if any. Of course, physics is the overarching subject of the sciences, but chemistry is that massive part of physics, really, that applies to us, the science of life, the science of chemistry at room temperature, mainly, okay? Which is fundamental to the way that you are born and the way that you live your life, based on the numbers 1, 3, and 5. And that's a deep understanding of science and very exciting when I first discovered it, at least for me. Try not to be one-dimensional. And now I'm going to tell you something about how I ended up as a scientist. In fact, when I was a kid, I didn't want to be a scientist. I didn't know anything about science. What I really wanted to be as a kid was Superman. Yeah, that's true. And actually, here's a photograph to prove it. There I was, a bit scrawny, I guess. My problem was I couldn't fly, so I had to find something else to do. So what did I do? I played tennis, okay? And I did gymnastics. And I actually acted in a play, Henry V, at school. And I thought I'd show you a picture from this play, one of my favorite pictures, because, well, actually, I'm the handsome guy on the right here. The guy in front, he became an actor. And I always tell young people, don't become an actor. Become a scientist. Because the guy in front, he became a famous actor, but he's now 5,000 years old. And I'm a lot younger than he is. There you go. So become a scientist. You don't get so old. Well, Ian and I were in the same year at school. And, of course, he's a fantastic actor. And some of you will know him as in the X-Men and in the Lord of the Rings. So that's the situation. Do other things. Another thing I did was graphics and drawing, and I did a lot of drawing when I was a kid at school. In fact, I still do it. In fact, I did a lot of graphics of various kinds. Okay, let's take this out of here, and let's see whether we can get into this a little bit more. Okay, here are some of my drawings at school. I drew cars and things like this, and I did tickets and posters. When I got to university, I did a lot of drawing of brochures and posters of this kind, and this is the cover of the university magazine. When you go to university, do other things. Don't just do the subject. If you're going into doing classics, go and get involved with the newspaper, the university student newspaper, or the magazine, or do some sport and do some other things of this nature. So I did all these, and it's very important. In fact, my first award was not for science, it was for this design, and in fact, here it got into the newspaper, and I used to look like this. And I don't look like that anymore, I must admit, but that's the way I once looked. I do logos of all kinds at the moment, okay? And in fact, I redesigned the Japanese flag, shown here, and this stamp. And there are various other drawings that I was very pretty good at, okay? And finished off with one other thing. This is a drawing that he did at school, and I only got good for it. And I was so angry that I only got good because I thought I should get very good that I decided to do science. Well, that's not really true, but that's the way it was. You can never tell where key ideas might come from. And one aspect of this is architecture, because I was interested in architecture. Okay, and in fact, in the discovery of C60, architecture was very important, and we'll talk a little bit about that later. Let's talk about science. My definition of science is that there are aspects of science. What are they? The body of all knowledge and understanding of the way the physical and natural world work. Okay, that's what you learn at school. And then there's the application of that knowledge, technology. And then there are the numerous ways in which this knowledge is actually discovered. That's the scientific method. Those are three quite identifiable aspects of science, okay? But before science became useful, it had another name. It was natural philosophy. And really, because it's so useful, people have forgotten that it's actually a very important intellectual and philosophical construct. In fact, the most important aspect by far is that natural philosophy is the only philosophical construct we have devised to determine truth with any degree of reliability. Now, I think that's so important, I'm going to say it again. Natural philosophy is a definition, is the only philosophical construct we have devised to determine truth with any degree of reliability. That's a very important statement. And the ethical purpose of education must be to teach our young people, that's you, how they can decide what they're being told is actually true. That seems not unreasonable, right? The teaching of a skeptical, evidence-based assessment of all claims, without exception, is fundamentally an intellectual integrity issue. Without evidence, anything goes. Think about it. Okay, well, let's think about science, because it's really an interesting thing. Pierre Abelard in the 12th century, a French religious philosopher, said basically in his book Sic et Non, by doubting we come to inquire, and by inquiry we arrive at truth. It's a very important statement. In short and simple but profound sentence lies a complete description of science, really. Of course, doubt and questioning are intrinsic threats to the power of those who depend on dogma for their authority. And Abelard got into a lot of hot water, as some of you might know. Francis Bacon in the 16th century produced a book. It was called Novum Organum. It's the book of scientific method, where he actually delineated it. And in Latin, Novum Organum means new instrument. Just look at that. Science was new in the 16th century. This idea of evidence for truth was new. Before that, people thought that you get into the holy books, the scriptures, for the truth. That was all blown away by this new instrument. We went from fact, hypothesis, to physical law. Now, if we take Pierre's rule, by doubting we come to inquire, and by inquiry we arrive at the truth, and invert it, okay, we come to arguably the most profound statement of all time. To determine truth, we must doubt and inquire. Okay? This has explosive consequences. And only when natural philosophy has triumphed over dogma-based authority have both democracy and science developed. Look around at those countries where there's no democracy and no science, and you'll discover that they're countries where natural philosophy, where truth-based and evidence-based analysis are not accepted. That's an important observation. Don't think about rewards. The Nobel Prize, well, I never thought about it. Don't even think about it. I never expected to win the Nobel Prize. I needed a job. I was fairly good at chemistry. I went into it because I was interested in it. Focus on doing those things that really interest you personally. Forget about the rewards. It must be what you're doing at this moment that interests you, and that's important. And so attitude is the important thing I want to tell you about in the last part. I have one piece of very simple advice. When you do an assignment or a job, make sure you give it your best shot. If you're satisfied with second-rate effort, think about it. Look for something else where only your best will satisfy you, not the teacher, you personally. And if you do that, you'll invariably find that you'll do things better than other people who might be smarter than you. There are lots of people smarter than I am. There are lots of people who could do what I do better, but they're not as dedicated as I am to this. They don't spend the time. If I do something that interests me, I might find that it's start in the morning at 9 o'clock or 8 o'clock in the morning, and then at 3 or 4 o'clock in the afternoon, I realize it's way past lunchtime because I've been so focused and interested in what I'm doing. I don't think it's actually enjoyment. It's just, wow, you're so engrossed in what you're doing that it doesn't matter what time it is. You don't mind missing lunch. Oh, working 24 hours a day maybe, way past midnight because you're so interested in what you're doing. If you do that, then you'll be successful. Okay, I guarantee it. And so we come to this. I hope you'll enjoy this presentation. You're coming by GeoSet, and I'm hoping that many of you will help by recording GeoSet projects to yourself and making recordings, and that you can give yourself to all the other kids on the planet and contribute to a global cache of knowledge, the sort of knowledge that you personally find fascinating. That's what we want. Not what I want, what you want. Thanks a lot.